In 1980, 3 siblings were each given $1,000 as part of the inheritance from a deceased uncle. The siblings agreed to invest their money individually and come back years later to see who had amassed the most fortune. The oldest brother, Alan, put the $1,000 into the bank. Each month he would add $62.50 to the account, or $750 a year. The sister, Bernice, invested her $1,000 in various money market accounts and earned 12% interest each year, which was compounded annually. Carl, the youngest, put his money into technology stocks. Their value climbed according to a parabolic curve until it peaked at $20,600 in 1994. By 2008, the stocks had fallen back to their original value of $1,000. So the first thing we need to do is determine each sibling's financial history, or which sibling's financial history matches each graph above. Carl's is probably the simplest, right? How do you know Carl's is the simplest? Well, it does say something like that, but it's actually parabolic, not parabolic. But that's okay. That sounds like some sort of disease. Okay? So, how are we going to state that? Carl's graph is what? Parabolic, exactly. Carl's graph is parabolic, okay? We have 2 other choices. What are they? Clearly Alan and Bernice, but in the graph, what other choices do we have? Okay, let's say for a second a line. We have a line and a curve. What kind of curve is that? It is exponential. Very good. Okay? So whose is whose? We have Alan and Bernice left. Okay? Alan's is a line. Bernice is exponential. Okay? So, we need to write function rules here for each of them. So, what kind of function rule do you think we're going to write for Alan? We're letting x equal the time in years since 1980. Okay? So, what is Alan's function rule going to look like? 1,000 plus 750 to the x? Well, you told me in a minute ago Alan's is a line. If I put the x in the exponent, that's exponential. 750x, okay? Because he started with 1,000 and added 750 every year, right? Okay. What about Bernice? Goodness, I wish we would have done exponential functions lately to remember how to do this. A times b to the x power, correct? What was a? The starting point, right? So it's 1,000 times b. What's her b? Why is it 1.12? Very good. It is increasing, okay? To the x power, okay? What about Carl? Poor Carl. He is the youngest. They're usually the dumbest. Oh, no. If you really thought I meant that, I should leave. Okay, so what should I do, guys? What should I do? I probably need to plug in points. Do we remember how to do that? We should if we don't. So let's remember together. Where am I going? Lists and spreadsheets. Okay. What is my first value going to be? So time, years, either one, right? Time. And what's this one going to be? Money. Okay, M-O-N-E-Y. Okay, so what kind of time values do I have? What do we know? At 0 time, he had $1,000. 1,000 monies. Okay? Some people's grammar is gooder than other people's grammar is gooder. Okay? Do we know another point? Oh, where did you get 14? I don't see anywhere that it says 14. Okay, so it shows you on the graph, so you're just reading the graph, but where did they get 14? 1994 doesn't mean 14 to me. Oh, so 1980 is when x equals 0. So in 1994, that would be 14 years later. Okay, 14. Guys, if you really don't think that I know what I'm talking about, you should fix your grammar. All right? Okay. So how much did he have at your 14? 20,600? Okay, I have 2 points, right? I should be able to come up with an equation of parabola? Why not? I need 3. Okay, so what's my last point? 28 and 1,000. And where did that come from? Okay, so now what? Add a page. Control doc to add a page. Data and statistics. So the label down here needs to be time. The variable over here needs to be money. So does this look like the graph we were given? But I mean the points, right? The points are good? Okay, so how do I get the function in there? Menu. 4, analyze. Regression, what kind of regression are we looking for? Quadratic. Okay. So, negative 100 x squared plus 2800x plus 1000. So use these functions to complete this table. Then tell which sibling had the most money at each given time. So how do I get a table now? Enter all of them? Okay. 1,000 plus 750x tab 1,000 whoops 1.12 raised to the x power negative 100 x squared plus 2800x plus 1000. So my graph here clearly does not look like my graph up here. Okay, if I just really want to, I need to, what? Thank you. I need to fix my window if I want to, right? So from 0 to 28, counting by, how about 14s? From 0 to, wow, we're amazing. So Control T, right? Control T. Okay. So like Joe suggested, we can actually change our table settings to give ourselves less work, right? Count by 5s instead. Okay. So I put them in intentionally in the same order that they're given, because then it's the same order on the table that's given as well. Okay. So I have 4750, 8500, 12250. Oh, thank you very much. 1600. 1600. And then 25, 19, 750. So B, 1762, 34, 3105, 85, and then I have to jump to 20, right? 96, 46, 29, 17,000.1. And then C, okay, so who had the most after 5 years? Carl. Who had the most after 10 years? Carl. Who had the most after 20 years? Carl. Who had the most after 25 years? Alan. Okay. It is given that Carl had $1,000 after 28 years. How much did the other siblings have at this point? Well, I have to go back and adjust my table settings, don't I? I just want it to start at 0 and go by... Well, I don't want it to start at 0, actually. I'm going to start at 27, and I'll show you why in just a second. Fair enough? Count by ones. No, but look what shows up. I started at 28. 28's right there. I'm slowly figuring this calculator out. Okay? It does start at 27, but 27 is right there underneath the top of the table part. Yeah, I don't want to. That's lazy. Okay? So Carl had $1,000, right? We should prove that out. Oh, look. It works. Okay? So how much did Alan have? Alan had $22,000. And how much did Bernice have? Don't judge people's names. After approximately how many years did Alan and Bernice have the same amount of money invested? How would you figure that out? We'd find the intersection, right? Okay, so how would we do that? Get off the table. Looks like I need to change my Windows settings just a little bit, yes? Let's go to 25,000. Whoa, not that. Because where I need to find the intersection is that right there, right? So menu, analyze, find the intersection. And it's asking me which graphs. Do you see that? So I want that graph and that graph. Then I have to do the lower bound and upper bound like normal. Okay? So where's the intersection? This is what it says for the intersection. 27. I'm going to control click that so I can move it so I can see it. Okay? So it's 27, 2.12E4. That's a good question, and we need to talk about that. Okay? Times 10 to the 4th. Okay? So that means 1, 2, 3, 4. I have to add 2 zeros there to get times 10 to the 4th, right? So it is 21,200. Okay? Yeah. I don't know either. It's probably just this operating system. Okay? So what does this mean? What does this point mean? After 27 years, Alan and Bernice both have $21,200. Okay? After approximately how many years did Alan and Carl have the same amount of money? Same kind of way, right? So I need to menu analyze intersection of which two? Which one was Carl's? The parabola. And which one was Alan's? The line. So there and there. And I need to move that over here so I can read it. So the point looks like this. So what does that mean? After 20 years, 20.5 years, right? Alan and Carl both have how much? $16,400. Okay? For the record, guys, that is rounded, just so you know. Okay? So what about number 7? Bernice and Carl? Do it again. Menu. Analyze. Intersection of Bernice and Carl would be exponential and parabolic, right? We're doing Bernice and Carl, right? What did I do? Okay. Okay, we're almost finished. Stay with me. After 22.7 years, Bernice and Carl. I don't know what that says. It's supposed to say Carl. Both have $13,100. Okay? One of the problems above can be solved algebraically, like without a calculator. Which one do you think it is? Which one? You think this one, Bernice and Carl? You think it could be all of them? Knowing what we know now, probably yes, but which one would be the easiest? Probably quadratic and linear would be the easiest, right? Alan and Carl? Okay, which would be 6. So, how do we solve it algebraically? If we're trying to see where they intersect, we have to set them equal to each other. Very good. Okay, so we have 1,000 plus 750x equals negative 100x squared plus 2,800x plus 1,000. At least we get to work with smaller numbers, right? Okay, how are we going to solve this? How are we going to solve this? It is a quadratic now, so we got to get x. We have to get it equal to 0, right? So let's subtract 1,000. Oh wow, that's 0 and that's 0, right? And let's subtract 750x. How do we solve a quadratic like this with no constant at the end? Oh my gosh, wouldn't it be factoring? So could I factor out? What if I factored just an x out? What's left? And if these two multiply together and they both it equals 0, it has to be true about one of them. One of them has to equal 0. Is it the x? Or is it the negative 100x plus 2050? Well, I just don't take a chance and do both of them, right? So if I subtract 2050 from both sides, negative 100x equals negative 2050. Dividing both sides by negative 100. X equals... Oh my gosh. But why is there two answers? So we're saying the quadratic and the line really intersect in two places? Oh my gosh. Okay. Any questions about this? Do you see what I mean though when I say we're going to be having to do stuff we've done before but with new and different kinds of functions? Okay? We've done systems of equations before with two lines. Now we're going to be doing it with more stuff like quadratics and exponential functions, things like that. Okay?